Okay, guys. Good morning. I hope you had a good day yesterday. A few of you still need to submit some work from yesterday, but I'll give you until the end of maybe the weekend on that, just so you can get sorted. There's some really good work coming in though now on OneNote. Please continue to upload it to OneNote rather than sending me an email. It helps me massively. I can mark it much easier. So just remember, go onto your page, click on whichever page you want, and there it goes, and I've marked Amelia's work there. So please do that. In order to go on the right page, you press insert at the top there, print out if it's a PDF, and a picture if it's an image, and then just it uploads immediately on here, and it looks really nice and neat. So please continue to do that. Right, okay. I'm going to disappear in a minute. We're going to go straight into the lesson. Okay, so here we go. Right, okay, so today we're doing the last bit of numerical methods, and this is the last bit of teaching I have to give you before we move on to the pure, the further pure, which is quite exciting. So it's numerical methods, but it's applications. So applications, make that slightly fatter. Applications using numerical methods. Okay, applications using numerical methods, and I'm going to use the example from the book here, which is on page 286, and it tells us, it gives us this expression: fx is equal to 15,000 0.85 x minus 1,000 sine x. Okay, and it tells us that is the value of a car, I think. So x is in years, and fx is the value of the car. Okay, right. So the first one, it says, so question A: find the value. Find value when after 10 years. After 10 years. Okay, well that's pretty straightforward. You literally put 10 into the equation. Okay, so you put it in to the equation, and if we do that, now you've got to be a little bit careful if it's in radians or degrees here, but the assumption is you've got to assume radians unless told otherwise. Now that I say that, obviously you may know the story of me using radians in my previous job and making a big mistake, but in pure mathematics we tend to use radians unless we're told otherwise. So assume it's radians unless otherwise, which in this case it doesn't tell us, so we're going to have to assume it's radians. And the answer, the value of the car, is after 10 years is £3,500, and that's to two significant figures. Okay. Right, part B is show that fx has a root. So show fx has a root between 19 and 20. Okay, so show it has a root. So between 19 and 20 years, what this means practically, that's when the value of the car will be nothing. Okay, so after 19 or 20 years. So in order to do that, you put in 19, which is, let's have a look. Put in 19 and you get, I think you get an answer of 534 approximately. You put in 20 into the expression, it's minus 331, and then you must write the statement. So you must say there is a change in sign and the graph is continuous. Therefore, a root lies between 19 and 20. Okay. Now, I did notice a few of you got a little bit lazy on that, not writing that statement. That is so important. This statement you must write. And I'm glad Billy's sister, if you're watching out there, Nancy, thank you for emphasising that to Billy and his work. That was much appreciated. Please continue to be harsh on him. So that's part B. C, it's find f dash x. We're finding the differential of that expression. Now let's just see that expression again. So this might not be too easy to differentiate this one. Fx equals 15,000 0.85 to the power of x minus 1,000 sine x. Okay, right, we need to differentiate this. And I'm going to do a bit of side working here because the first one's not super easy. So a bit of side working. Do fast forward if you think you can get the differential really easily. I'm going to break it up into two sections. So I'm going to do that section first, this section first. So I'm going to let y equal, because you can differentiate them each separately, that's fine. 15,000 0.85 to the power of x. Okay, now we need to differentiate that. Now do not just reduce the power by 1. That is then a legal move. What we need to do, there's a clever trick here. You need to ln both sides to begin with. 15,000 to the power of x. Okay, I'm going to use ln laws now on the right side. Plus ln 0.85 power of x. Ln laws, you just add them. I'm now going to bring the x down in front. Ln y equals ln 15,000 plus x ln 0.85. Okay, I'm now going to differentiate this implicitly. So ln y becomes 1 over y dy dx. Ln 15,000, well, that just disappears because it's a constant. And this, we've got a constant times x. So constant times x just differentiates to the constant itself. Okay, so if I multiply both sides by y, I get dy dx, which is what I'm after, equals y ln 0.85. Now y itself, if we go back to the start, y was equal to that, so I can substitute that back in. Dy dx equals 15,000 0.85 x times ln 0.85. Okay, now that's quite a lot of work for that bit, and after a while you'll start to spot the quick ways of doing these. But I know straight away now I can differentiate that function. There is going to be 15,000 0.85 x ln 0.85. Okay, now if I differentiate sine x, well, you should know sine x just differentiates to cos x. So I'm going to change that to cos x there. Right, okay, so that's part C, and you can probably predict what I'm going to be using that for in part D. So part D, taking x0, taking our first approximation, it's 19.5, apply the Newton-Raphson method once to obtain a second approximation. So remember, if we go back to the Newton-Raphson method, the next one is equal to the previous one minus f x over f dash x. That was in the previous video. So our next value is equal to 19.5 minus f of 19.5 over putting 19.5 into the differential. So you put that into the original. That is putting it into the f dash x. And I will just give you the answer for that. The next value, x1, is equal to 19.528. And again, I think Philip asked the question last lesson, how do you know to start with 19.5? Well, it's a little bit of an educated guess. It's one of the limitations of using the Newton-Raphson method. You have to give a starting point. But 19 years for an age of a car is not terrible. Okay, Right, so that's roughly how, and in context that means anything more than that, that's when the car is worth nothing. So it then says criticise the models. What's the practicalities of this model? Well, I suppose beyond 19.528, the car will have negative value, which is not really practical. Mostly the car will have some value, but over that years, the car will start to have negative value, which is not really practical. Okay, right, now these questions on the next exercise is I want you to do a bit of a mix really. I'm going to do so exercise 10D. I do want you to just do question 3, 4 and 5, and that's on page 287. And then I do want you to do loads on the mixed exercise, but I want you to also do the mixed exercise. I want you to do, I'm just going to make you do questions 11 and 12, maybe 11 and 12. So there's not too much to do, there's 5 questions there. That's on page 289. Okay, coming up, guys, that's pretty much the end of, I'll be speaking to you next week, but what I'm going to do is I'm going to set you a series of papers to do on Dr. Frost. More details will follow, so you will have some work to do over Easter as consolidation before we move on to the further pure book, which is really, really exciting. Okay, have a great weekend, guys. Stay safe. Hopefully enjoy the sun though, and I'll speak to you soon.